Hi everybody, back again on binomial probability. Now I want to demonstrate how what I was talking over here about theory we can do over here in Excel. So let me put in today's date, equal NOW, open paren, close paren. That's just a fun thing to do so that we can continue with creating three variables, K, N, and P. K, let's use uppercase, K, N, and P. So K is going to be the number of heads, N is the size of the sample, P is the probability of heads. Let me remind you how we set things up like that. Suppose K is 5, and N is 13, and P is 0.5 for a fair coin. When you select both columns on a PC and go to the formulas bar and say define names down to create from selection, you automatically introduce those variable names with those values. And if you pull down the name box list, you can see that K, N, and P are there. And as you know, I like to highlight in yellow when I've created some names and click all borders to put frames around these things. Now, if I just type anything in some arbitrary cell with K in it, like K squared, I get 25 because 5 times 5 is 25. That's just a little check that I really did define these things. Okay. But K really is the value of a random variable. What random variable? The random variable that counts the number of heads in a sample of size 13. So I'm going to create a column here for the possible values of K. Now, the values of K could mean no heads, 1 head, 2 heads, 12 heads, 13 heads, but no more than 13 heads. So I needed to create the possible values of K from 0 to 13. So I'll put a 0 and then a 1. If I select those two cells and hover my mouse over the lower right hand corner, you see the mouse changes from an open cross to a black cross, and press down the left mouse button and drag down, you'll see that so far it's up to 11, 12, 13. You can see the 13 there, right? Okay, and that gets filled in automatically. Some other time we'll talk about how flexible that capability is, but for now it's a nice way to automatically fill out the numbers we need for K. Now I'm going to select column D and center it because I happen to like numbers centered in columns. And what I'm going to do is I'm going to calculate for each value of K the probability of that many heads in 13 tosses of a P coin, where right now P is 0.5. So I go to this cell E2 here and enter equal BINOM.DIST, and then I click on at the left in column D for the value of K that I want to put into the formula. Then I put an N, comma, and a P, comma, and since I want the point probability, what MyStatLab often calls the exact probability, I'll put a 0 there for the point or exact probability. And for the particular value of K, the probability of no heads, which means, of course, the probability of all tails, turns out to be 0.000122. Okay, what I want to do is I'm going to copy that formula down all the way to the row with 13 in it and do a Control D, and now I have all these probabilities. And already you can start to see a pattern here, but let me select column E and right justify it, fine, but I also want to tell it how many places to the right of the decimal point, so I'll bring them down a little bit. Let's get that, bring that down a little bit. Or bring it up. So these buttons, oh, you know why that isn't working? Here's a bug. Check this out. Notice that my data type for this column E is general. What we really want is that it to be decimal numbers. So I select number here, and now you see the number of decimal places that I want. And now I can start to see the pattern. You see, for all tails, the probability is 00012, and for all heads, the probability is 00012. And you can say, that's interesting, but it's more important to realize that this whole column of numbers is symmetrical. One head is 0.00159. One tail, which is 12 heads, is 0.00159. And if you look at this very carefully, you see that it's perfectly symmetrical. Why is it perfectly symmetrical? Well, because we've got a perfectly fair coin. If I change this to let's say a 0.35 coin, in other words, 35% of the time this coin has come up heads, you see that it's not symmetrical anymore. But it's very hard to look at a bunch of numbers to see whether they're symmetrical in any way. So let's make a graph, okay? And this is a general procedure which can be used for pretty much any two columns of numbers that are of the same height. And the one thing that I do to make sure that it comes out a clean graph is I got to put something at the bottom of the left column. You can put almost anything. In this case, I'll put the word end. Okay, that's the end of the values for the random variable. Okay, now I want to create a graph, so I select both columns and including the row with the word end. Okay, go to the Insert tab, and you see this thing for inserting a column or a bar chart. Click on that and tell it you want a two-dimensional chart. And we're done. There it is. There's the graph of this data. Notice the word end appears off the right end of the values for K. And also, you look carefully, you see, this graph is not perfectly symmetrical. Notice that, well, the two middle columns are definitely of unequal height. In fact, the right side goes down rather slowly compared to the left side. How shall I put that? Well, let's exaggerate it a little bit more and change it to, let's say, a 0.2 probability of heads. And now you see the left side goes down fast and the right side goes down more slowly. They call that a graph that is skewed to the right. And that's because it's not a fair coin. If I put it back to 0.5, like that, now it's perfectly symmetrical. Okay? So, relative to the left-hand side of the lecture over here, what we're looking at are the values of BNPK, where K goes from 0 to 13, and P is equal to 0.5. N is 13. Okay? In this left-hand side, we also talked about cumulative probability. So, for example, if I want the cumulative probability for 0, 1, 2, 3, 4, or 5 heads out of 13 coins, then, well, there's a number of ways to do this. The easiest thing to do without any work at all is to select these point probabilities down to 5, starting at 0 down to 5, and if you look down at the very bottom of your Excel, you'll see that the sum of those numbers is 0.29053. What we just did was this row here from the lecture. We added up these point probabilities represented in the BMPK notation. But we also see on the left in the lecture that we could use a 1 at the right end of BINOM.DIST to actually get that sum automatically. So let's just put that somewhere convenient. I'll put it right here. Equal BINOM.DIST, and then we're going from 0 to 5, including 5 for N and P, and then we're going to go cumulative, so I put a 1 at the right end. And there's a 0.290527. Now, is that the same number I got before down at the bottom of the screen? Well, at the bottom it says 0.29053, and I'm saying 0.290527. Why? Because this has 6 decimal places, and down there I have 5. If I select that cell and take away a decimal point, a place rather, now it's 29053 in complete agreement with the bottom of the screen. Okay.